So in lesson 2.2, graphing quadratic functions in vertex form, we're going to be reviewing vertex form. Our objective is I can graph quadratics in vertex form and I can complete the square. So if we have an equation in standard form, we can use completing the square to change it into vertex form and then graph it from there. So keep calm and make parabolas. So here's a review of what vertex form looks like. And this is your basic equation in vertex form. And it has an A, H, and K, those three letters right there. A, H, and K. Those are going to be replaced with numbers in the equations we're going to be looking at, but they represent different things, different types of transformations that happen to our basic x squared quadratic function. So A means that my graph is going to be skinnier if A is greater than 1, because it's going to make it taller, do a vertical stretch, times it by some number greater than 1 to make it taller. It's going to be wider, like shorter, fatter, if A is between 0 and 1. And then if A is positive, that means it opens up. Just like our regular function, you can see on the right side that x squared opens up. And then it opens down if it's negative, so it's flipped upside down across the x-axis if A is negative. And then we have H, which sometimes is the hardest one to identify because that minus sign, there's a minus sign there, but H is only the number that comes after the minus sign. So H is not included in the minus sign. And then that tells us if it's been shifted right or left. And then K is our vertical shift, whether it's open, where it's shifted up or down. So let's write some notes here. If it's a minus sign, then it's going to go to the right, which seems weird, but that's the way that it is. Right if it's a minus, and then it's go left. It goes left if there's a plus sign there, just because we have that minus sign as a part of the formula. So if there is a minus sign, that means H is positive, and if it's a plus sign, then it's the opposite. Okay, vertical is exactly what you think it's supposed to be. So vertical means it's going to go up if there's a plus sign, and then it's going to go down if there is a minus sign. So those two transformations, the horizontal shift and the vertical shift, they help us decide where our new vertex is going to be. So over here, you will see the basic y equals x squared function. So once you know where the vertex is, in this case, it's at 0, 0. It's always that point at the very bottom of the parabola, or it's at the top if it's flipped upside down. That is the vertex. That's the main point, because that's where the symmetry, the line of symmetry runs through there. And so it looks the same on either side of that vertex. So once you know where the vertex is, then you can make a table just like that. We're going to plug some numbers in today so that we can practice doing that and making the table, so we can look to see, after we know where the vertex is, we can figure out what the graph of the rest of the graph looks like. And there's a couple different ways of doing it. So table, but then also knowing that looking at this one, you can see the pattern of the regular function is that the first point goes over 1 and up 1. The second point from the vertex is over 2, up 4. And the third one is over 3, up 9. And it's the same on the other side. So if it's going to be like a vertical stretch by 2, then it's going to be twice as tall. So maybe I would go over 1, up 2. And the second one would be over 2, up 8, because it's going to be twice as tall. So we'll practice that in the next in the first example, which is right here. So we have those two things off to the side to remind us what the graph looks like, what the equation looks like, so we can identify some things. So in this case, let's identify our A, H, and K, so we know what we're working with. So just looking at our function, A is the number in front of the parentheses, so that's 2. H is the number inside, and remember the minus is not included in the H, so our H is actually positive 4, and then the K is our number on the outside, which in this case is negative 3. The only weird one is the inside. So we have A, H, and K, and so from there, probably something to add to your notes is the formula for the vertex. Usually it's at 0, 0, unless it's been shifted to the right or left, and up and down. So in our case, this has been shifted right and then down. So that HK, those two letters right there, are going to tell us where our vertex is. That's why this is called vertex form, because if it's written in this format, it is so easy to see where our vertex is. So over here, my vertex for this example is going to be at 4, -3. So 4, -3, I'll just put that right on the graph because I know where it is and I don't want to forget. So there you go, 4, -3. And what does A tell us? So looking at A over here, that tells us if it's going to be skinny or wide. And A is bigger than 1, so that means this is going to be skinnier. It's going to be taller than it was before. So again, we can do a couple things. So over here, from the vertex, we go over 1, up 1, but this time A is telling us that is going to be 2 times as tall. So from here, if I go over 1 on our graph, then I have to go up 2 instead of 1 because that would be twice as tall. Here, for the second point, it's over 2, up 4. But here from my vertex, if I move from the vertex, I go over 2, up 1, 2, 3, 4, 5, 6, 7, 8 to do my next point. And my axis of symmetry, let's talk about that again. Axis of symmetry is the line that runs straight through the middle of your graph. That tells straight through the vertex, so like right here. And that equation is x equals 4. It's the very same x value as the vertex. It always goes to the vertex, meaning that if I put this point on the right side, then I can put that same point on the other side because that axis of symmetry acts like a mirror. It's a mirror image on either side of this axis. And so it makes it much easier to graph. I don't have to plug in as many numbers. And then once I have those numbers, then I can connect it, make sure it's connected with a curve. That wasn't super amazing, but there it is. It's connected with a curve. And another way that you could do that, if that doesn't make sense to you, of like it's twice as tall or 3 times as tall, whatever, then you can always make a table. So I know my vertex, just from vertex form from HK, is at 4, -3. And so if I want to know what the rest of my graph looks like, I'm going to plug in numbers on either side of X. So I'm going to plug in 2 numbers on this side, 2 numbers on this side, and then plug those into my equation up here so that I can get the matching Y values. So then if you go in and you type in 2 parenthesis 2 minus 4, or 3, whatever you want to plug in first. I'm going to plug in a 2 first. 2 minus 4 squared, and then a -3 on the outside. Then we get +5. So then my graph, I have to have a point at 2, +5. So 1, 2, 1, 2, 3, 4, 5. Good. So that's going to be that point right there. And then if I plug in a 3, same thing, plug in a 3, I get -1. So 3, -1, that's that point right there. If I plug in a 5, I also get -1 because this is the point of symmetry, right? The same thing is going to happen on either side. And then 6, 5, which gives me exactly the same points as I came up with before. But if that makes more sense to you, go ahead and do it that way and make a table for all of your functions. And then you can figure out your points from there, and that will help you graph. So there it is, written out a little nicer, and we'll move on to our next example. All right, this is a vertex form again, so identifying A, H, and K. My A is -1/2, which means since it's negative, that means it's going to open down. It's been flipped upside down. H, in this case, is -2. Remember, it's opposite of what you think it's going to be. And then K is -1, that number sitting there on the outside. So my vertex, just like the formula says over here, my vertex is going to be at -2, -1. So let's put that on the graph, -2, -1. And the axis of symmetry is going to be x equals that very same x value that we used for the vertex. So if we want to write that onto the graph, it's not a part of the function, but it does help us to graph the function a little better, a little easier. So this time I'm just going to start by making a table. I know my vertex is at -2, -1, so I'm going to plug in 2 numbers lower than this x value and 2 numbers higher than this x value. So we're plugging all of these x values up into this x, into this function right here. So negative 1/2 times negative 4 plus 2 squared, and then minus 1 on the outside. And then, so when I plug in a negative 4, I get negative 3. I plug in a negative 3, doing the same thing, I get negative 1.5. And so the same thing's going to happen over here. I get negative 1.5. That axis of symmetry is really nice. It kind of cuts down on the work. And then when I plug in a 0, I get negative 3. Okay, so I can plug in my points from there. So negative 4, negative 3. So we knew this was going to open upside down, and then it's symmetric, so I have that point over there. Negative 3, negative 1.5, so that's kind of in the middle, but that's okay. Symmetric on that side. And then there we go. We can connect it with the curve, because it has to be in the shape of a parabola. No straight lines on these graphs. Okay, so now it's given to us in standard form on this example, and we have to figure out how to change it. So, some instructions on completing the square. And what it means by completing the square is we're looking for something that fits into this kind of rule. So like x plus 2 squared. That is a perfect square. So like when I take something and I factor it, I want to end up getting exactly the same factor here and here, so I can write it as a square. So that is the goal. So the only way that I can do that, I'm going to try to erase this over here. The formula, we have a formula for being able to do that. So we're going to kind of ignore this plus 4 over here, and we're going to focus just on our x squared and our x term. So what needs to happen over here is we are going to start with x squared minus 2x. And then we have to figure out, okay, what number is going to make this into a perfect square? And so in this case, what you have to do, so the formula for completing the square is if I have x squared plus bx, and then you have to figure out what goes here. You take b, and you divide it by 2, and then you square it. So for us, we're going to take b, which is negative 2, and we're going to divide it by 2, and then we're going to square it. So we can't just add things, we have to make sure that we're doing this right. So from here down to here, that's going to help us figure out what we need to add there. So x squared minus 2x, and let's figure this out. So negative 2 divided by 2 is negative 1, and then when I square that, that gives me plus 1. But I cannot just add 1 because that's changing the format. So I still need my plus 4. But then if I add 1, I have to offset that. So I also have to minus 1, because if I add 1 minus 1, that doesn't change the value anymore. So if I add and subtract the same number, then we're okay. Because if I combined those two like terms, that one and that one, then I would get exactly what I started with. But I need it in this format because this right here, when I factor this, it's going to give me x minus 1 and x minus 1. And then I can combine these two like terms on the outside and still have plus 3. So, but the goal is so that I can write this in the format of that being squared and then have a number on the outside. And it doesn't matter what the number is on the outside. We just want to make sure we get this number right here to be exactly the number we need it to be so that I can write that as a perfect square. And now it's in vertex form. So here we go. We can identify our A, our H, and our K. So for us, it's the number up front. If there's no number written up front, then it's automatically 1, because 1 times all that is the same as what it is right now. H is also positive 1. That's our number on the inside. Remember, insiders are liars. That's going to be opposite of what we think. And then K is positive 3. So I know my vertex comes from H and K. So 1, 3. Let's put it on the graph over here, 1, 3. And then my axis of symmetry is going to be x equals that very same x value that I used for the vertex, x equals 1. So we can draw that on there. And then we can make a table to figure out what these other numbers are going to be. So I know my vertex is at 1, 3. I'm going to plug in 2 numbers lower and 2 numbers above. And you can either use this equation down here that we simplified, or you can use the original equation up here. It will give you exactly the same x values, or exactly the same y values, no matter what you plug in. So in my calculator, I'm going to type in my x minus 1 squared, and then plus 3. But if for all of these x values, I'm going to plug in a -1, plug in a 0, plug in a 2, and plug in a 3. So when I plug in a -1, I got 7. When I plugged in a 0, I got 4. When I plugged in a 2, I also got 4. And plugged in a 3, I also got 7. So now we can graph this. So we have 0, 4. We know it's going to be symmetric, so we can fill in the other side as well. And then -1, 7, 1, 2, 3, 4, 5, 6, 7. Fit to the very top of our graph. Okay. And then we can connect our graph. Pretend like that's connected all the way down to the vertex. Okay. And there we go. So we just have to have the additional step of completing the square. So focus on those very two first terms, the x squared and the x term, and then figure out what you need to complete the square. So, so here it is, a little bit nicely written out. And here's our next example. It's a little bit different. So completing the square, again, we're going to focus on these very first two terms here. But this time, our goal is that we cannot have a coefficient in front of that x. We want to take that out. So my focus is there. I'm taking out a GCF of 2. X squared minus 8x, and then I'm going to leave that parenthesis open because, and then the 33 we're going to leave on the outside because we don't need it on the inside. That's not our focus right now. Okay, but we need to figure out what can we do, or what do we add there in order to complete this square. Do you remember the formula? So if we know what b is, we just have to take b, divide it by 2, and then square it. So for us, we're going to take -8, divide it by 2, and then square. So -8 divided by 2 is -4, and then squared gives me plus 16. But remember, I cannot just add 16 just because I want to. I have to offset it. If I add 16, I also have to minus 16. So in this case, if I add 16, I have to minus over here. However, I'm actually going to be minusing 32 to do the offset because I didn't actually just add 16 here. I added 2 times 16, which is 32. So since I added 32 here, then I had to minus 32 on the outside to offset what was happening. So now we can factor this inside. So this becomes x minus 4 times x minus 4, or x minus 4 squared. And then you can combine these two like terms to get a plus 1. And then we graph. Our vertex is at 4, 1, because that's my h and my k. Axis of symmetry is x equals 4. And then even before I graph, I know my vertex is at 4, 1. So plug in 2 numbers below, 2 numbers above, and go ahead and pause this and graph it, and then play the video and see if you come up with the same graph. So I type this in, 2 times x minus 4, but you're plugging in all of these numbers. Okay, let's see if this fits on my graph. So 4, 1. Let's my vertex, 3, 3. And then it actually goes off a little bit. And there we go. There's my graph. On this one, same idea. So focus is these first two terms. We take out the GCF, so we don't have a coefficient up there. So we're taking out a -1 this time. So we have plus 4x, and I'm going to leave a space so I can complete my square. And then the -7 is going to stay on the outside. I didn't take a -1 out of that one, so that one stays. Okay, so I take my 4 divided by 2, which is 2, and then we square it, and then we get 4. Okay, so if I added 4, I have to offset that on the outside, but did I really add 4? And the answer is no, I actually added 4 times -1, which is -4. So I really minused 4. So I need to offset that by adding 4. And then we factor this. So this becomes x plus 2 times x plus 2 when I factor. Combine like terms on the outside. And then here it is. Go ahead and pause. And then I'll jump to the screen that has the vertex, the axis of symmetry, and the graph. So here it is. We have the vertex at -2, -3. And it is going upside down since our A is a negative number. And we have our table that gives us the rest of the points that we need.